Hi, my name is Gia. In this video, I will discuss some theory about mathematical induction, which will be very important in the first few weeks of this course, the analysis of algorithm complexity. Okay, in this video, I will just discuss about the general description about mathematical induction. And then in the different videos, we'll discuss about some examples and also common mistakes usually seen when we prove something using mathematical induction. Okay, so in this video, we will discuss about the general description about mathematical induction. So what is mathematical induction? It is actually one of proving methods that can be used to prove that some properties hold for non-negative integers. Its principle is actually similar to domino effect. If you know domino effect, you can imagine that you have a row of dominoes placed upright, each separated by a small distance. So let's say you have some dominoes placed upright, and we have a small distance that is exactly the same between neighbors. Okay, and you upon pushing the first domino, the next domino in line will be knocked over and so on. So when we push this one, the next domino will also be pushed and so on. Thus, firing a linear chain in which each domino's fall is triggered by the domino immediately preceding it. The effect is the same regardless the length of the chain. So even if we have a very, very long chain, it will be the same. The effect will be the same. If one is down and it trigger the next domino, then it will also trigger the next dominoes until the end of the row. So if we consider or compare it with mathematical induction, integers also has the same distance between their neighbor, so that each integer can be considered as a domino in a row. You know, if we have integer, let's say positive integer, 1, 2, 3, 4, 5, and so on, the distance between each neighbor is exactly 1. And to prove that a property Pn is true for every non-negative integers n larger or equal to k for some non-negative integer k, the fall of the frontmost dominoes can be considered as the proof of the first some integers based on the given domain. So let's say we consider the integer as dominoes. Previously, in Domino's effect, it says that if the frontmost domino falls, it will affect the next dominoes, and the next domino will affect the next dominoes, and so on until the last row. This is the same as mathematical induction. If the frontmost integer has been proven true, and we can prove that the fall or the truth of the property in some integer, let's say this, will always be triggered by the truth of element immediately preceded. It means that a whole integer must be true if we consider the given property. Okay, so it is really close with domino effect. So in general, mathematical induction can be divided into 3 steps. The first one is the base case. So we can prove the base case first, and then we can determine what the induction hypothesis, and then we prove the induction. It is called the induction proof. There are 2 types of mathematical induction. First one is ordinary mathematical induction, and the second one is strong mathematical induction. The differences between the two can be seen in the number of base case and the induction hypothesis. So usually in mathematical induction, we only need to prove one n for the base case, but for strong mathematical induction, usually we need to prove more than one number in the base case. For more detail about the difference between the two types of mathematical induction, please see the next video. Okay, thank you for listening and see you in the next video.